Okay, so if we want to solve x squared equals 4, what do? I asked people to enter solutions, and I got x equals 2. Then I got something about some plus or minus x, so somebody's thinking along the right line. You put all that together, and you realize that there are two solutions to this. What number can you put in here to work? 2. That's the solution I got. But negative 2 works as well, because if you square negative 2, you get 4. Okay, well then, solution set from your graph would be negative 2, 2. What do I mean by that? I mean you go up to the graph, and you let y equal 4, and you find that x equals 2, or x equals negative 2. So the graph tells you what the solutions are. Also, negative 2 squared equals 2 squared equals 4. Quantity negative 2 squared equals 2 squared, which is 4. So both of these are solutions. So x squared equals 4 gives you x equals plus or minus the square root of 4. And I comment that if you have any even power, the same thing happens, because any even power gives you a graph that's symmetric with respect to the y-axis. It's not one-to-one. To do an inverse function, you're going to have to choose a branch, and usually choose the branch to the right of the y-axis and invert it. And then you can use that inverse function to solve the equation. So if you had x to the 6th equals 4, then the solution would be x equals plus or minus 6 to the 1/4. Now, more on that later. We did do one more thing. So let me flip the board here. Things a little messy behind that board, aren't they? Okay. Board covers up a lot of bad looking stuff. You should see the rest of the room. Okay. Basic inverse, the inverse of the basic reciprocal function. Y equals f of x equals 1 over x. So y equals 1 over x. You invert that, x equals 1 over y. You multiply by y, so forth. Well, the solution steps are easy. I've written them out. And you get y equals 1 over x, and you see that the inverse function is y equals f. I wrote f of x. I should have written f inverse of x, which is 1 over x. And you see that the basic reciprocal function is its own inverse, and you can work out yourself f of f inverse of x equals, and so forth. It's going to end up equaling x, but you need to see why, so you want to work that out. The basic reciprocal square function, what's its inverse? Its inverse is x equals 1 over y squared. Well, the function is y equals 1 over x squared. The inverse can be characterized as x equals 1 over y squared. Xy squared then equals 1, y squared equals 1 over x, so that y is the square root of 1 over x, which is 1 over the square root of x. So x, and that only works for x greater than or equal to 0, because the square root of a negative does not give you a real number. So there we have the inverse of the basic reciprocal square function. And again, you can check and see that when you compose these functions, you get x. Got to be a little careful with domains when you state things here, but it kind of works out. Okay, so another observation is this would just be a composition of the square root function with reciprocal square function, wouldn't it? Or with reciprocal function. So that's kind of interesting. But we'll talk about that later.